All right. All right. Cool. Hello everyone. Sorry for the delay there. I'm trying to figure out this YouTube live stream thing, but I am so excited to be here tonight. My name is Zoe. I am working for Lambda School as a school programs manager. And I am going to be talking to y'all tonight about uh, technology mindsets. So a little bit about me. I'm not a software engineer myself, but I've been around the field of software engineering at Lambda School for the past 2 years, and before that, um, teaching and in other capacities. And kind of my general philosophy in life is technology should be more accessible than it is today, and it should be more fun than it is today. And I kind of see it as like technology is everywhere. We just have to, think about where to look. So with that, we're going to be talking about some tech mindsets, how they appear in daily life, how they appear in work life, and the like. So get to it. Always like to start off with an objective. My objective today, by the end of this session, what we will learn is to be able to define Uber and identify examples where Uber can be applied in your life and in your work. So as I was, going through three things: algorithms, what they are, what they mean, do a little bit of a demo in Scratch, and then we're going to talk about some everyday tools that use programming type principles. Great. And just one housekeeping item: throughout this session, we will be using Slido. So this is a Slido code, and I believe the link is also in the description below this stream. So this is where you can ask questions, and I will also be asking some questions of you all. So to make things a little more interactive, I want to know who's here, and kind of cater it to y'all. So my first question is, what do you do for work? So you can go ahead and find the Slido. That question is open, and yeah, tell me what you do. Give it a minute or two here. It's all good. So my first question is, I think there is a bit of a lag between me and and what's going live on YouTube. So maybe these polls aren't the the best option here. Oops, lost an earring. All right. There we go. Let's see. We've got CPA, students, other people in tech, shopper for Instacart. Okay, cool, cool, cool. So this is good. I got to test out Slido and realize that there's a huge lag. But we will continue to use this as we walk through, and I'll try to throw in some examples that relate to you all as well. So cool. With that, let's move on. So like I said, we're going to start talking about what is programming generally. So as I was prepping for this, I did what everyone does and I Googled programming. And as expected, I got this screen of just a bunch of like really intense code. People like this guy in the bottom left hand corner, just like staring deeply into the soul of his computer. And this doesn't surprise me at all. When I was a sixth grade science teacher, I did this experiment with my students where I had them draw a scientist. Every single one of them would draw like a scientist in a lab with like crazy hair and like mixing potions. That makes sense. That's what we see on TV. It's what we see all around us. But my message to them and my message to literally everyone is that that is obviously just a stereotype, and that programming is not this. What programming is, it largely is solving problems. This actual code, like 15% of programming, it's a really important part of being a software engineer, being a developer, but solving problems is what you will spend the majority of your time doing and thinking about as a software engineer. And so that is what we're going to talk about today. I decided to poll some software engineers at Lambda School and ask them, like, what are some things that you think help with programming? And these were some of my favorite answers. The first one, taking toys apart and putting them back together, specifically Legos, was called out there. The second one, crossword puzzles, Sudoku. Third one, proofreading in your native language. And my favorite one, cooking with several people in a single kitchen. I really like this one because they said it's about like figuring out how to optimize work time across several people, figuring out which tasks depend on each other, supply chain management, managing dependencies. Super interesting because I would not think any of these things help you become a programmer, but I have real software engineers to tell me that they do, which is great. So cool. What we're going to talk about today is algorithms. Algorithms at their core are a series of inputs and outputs and a bunch of things that happen in the middle. This is how all computer science happens. All code works. There's an input, some stuff happens, there's an output. Usually there's a whole bunch of those chained together, and that's how the software that you experience every day works. What we are talking about today, tech mindsets, is how do people create these algorithms? How do they figure out what the input should be, what the steps should be, what the output should be? And Lambda's approach to problem solving is this method called OOPR. So OOPR stands for understand, plan, execute, and review. It's a step-by-step process by which we teach our students to approach computer science type problems. What we teach is that almost all problems are a series of sub-problems, and that you can use these steps, understand, plan, execute, and review, to solve every sub-problem and ultimately solve the bigger problem. So without further ado, I'm going to walk through some examples of these steps, and then later on we will apply them together. So as we're walking through these, I would challenge you to think of some problem or process in your life, whether it be your work life, whether it be your personal life, where you feel like you're doing a task over and over again and you think that it could be improved in some way. And use that as kind of the backbone for this whole lesson, because that's really what we're trying to get to tonight, is like problem solving processes. Great. So let's start here. We already saw this diagram. This is an algorithm. There's an input and there's an output. When we're thinking about OOPR, the first stage is understanding. So in this stage, you're just asking questions. What are the inputs that your code receives? What are the inputs that your project receives? What is the range of that input? Can we accept multiple types of input? How big can the input be? And then on the other end, what are the outputs? Is there only one output, or are we okay with different types of outputs? What size of that data can we accept? Are we missing anything from our task that we need to clarify? Tons of questions happen in the understand phase. A couple examples of this process, of like an algorithm process that would be day-to-day life. Kids submitting homework, they get a sticker. Paycheck deposited, you pay your bills. Customer enters a shop, you convert it to a sale. We're going to work through that last example of a customer entering a shop and converting it to a sale to kind of explain the whole OOPR process here. So if I'm trying to understand my task of customer entering a shop and converting it to a sale, I'm going to start with asking a bunch of questions about that. Do I know who my customer is? Do I know why they entered my shop? Do I know what kind of sale I want to make? Do I care if it's full price? Can I give them a discount? Do I have to make the sale that day? Can I make it another day, right? The first thing I want to do is just like really understand the parameters that I'm working in here. Some software examples that are analogous here, right? If you type in a website URL, you would arrive at said URL. If you click a button, do something cool, right? If you submit a form, send data back, that kind of thing. Great. So that's our understanding phase. And also, as we're going through this, if you have questions, please drop them in Slido, in the audience Q&A, or feel free to drop them in the chat, and I will get to them as I can. Awesome. So next step is planning, right? First, we've figured out the parameters. We know what we want to put in. We know what we want to take out. And then we have to think through what are the steps that we're going to take to get there. Usually this looks like a series of tasks. have it broken out here into task 1, task 2, and task 3. But let's think about our example of the customer entering your shop. When the customer enters the shop, maybe we want to greet them. Then we want to give them a 20% off code. That's probably a good step in making a sale. At some point while they're in your store, you want to check in with them, see how they're doing, maybe even give them a compliment on what they're picking out. I know my Trader Joe's cashiers always tell me like, oh, this is my favorite thing. And then that will get us to a sale at the end. This is our plan. You haven't done any of this yet. You're just like listing down the steps of, I think that if I have this input of a customer entering my shop and I want this output of converting to a sale, these are the steps that are guaranteed to get me there. For a software example, button click to doing something cool is my very vague term. I didn't want to go like too in depth with the steps here because I think for this beginner audience, it wouldn't make a lot of sense, but it would be something like gather the data in your database, right, or on your local machine, send it to the database, and then, you know, give the user that output, right? So you're pseudo coding out the steps here. Okay, next, you've tried your plan and then you got an unexpected output. Task 1, task 2, task 3, and then this did not result in what we expected. Customer enters shop, you greeted them, you gave them the coupon, you checked in with them, you complimented them, and then they left a terrible Yelp review. Oh no, what? This is a super normal and healthy part of software engineering. This is the testing phase, and it's really important. In this step, what we tell our students is you're thinking like a villain. Everything that could go wrong will go wrong. You've tried your thing, but all these problems are coming out of nowhere. And this is where you go back to your plan and you refactor it, right? You're thinking like, okay, clearly something happened that made the customer leave this terrible Yelp review. Next time I want to control for all of those things before my customer enters the shop. And then I can get the output I want. So this is when you're thinking about like lots of algorithms stacked together, right? It's controlling all of the things on the front end before working into your process. So some questions we might be asking here: does your implementation handle any kind of input? Does it handle a customer who's never been there as well as a customer who loves your store? Does it handle the customer who left the terrible Yelp review? Do we need multiple algorithms to deal with multiple different types of customers? That kind of thing. And maybe does this functionality already exist, right? Maybe there's a tool or a software or a person who can every single time convert this customer to a sale. Like you lean on those in the execution phase. And then, you know, an example of an execution that might not go through here is click a button, 404, no internet, right? You have to go back, think, why did this happen, and start to solve those in this execution phase. All right, getting somewhere here. In just a second, I'm gonna pause and make sure we don't have any questions, but almost there. This is our last one, reviewing. So after something went wrong, oh no, horrible thing happened, you've fixed that problem, you have your clearly defined input, your clearly defined output, and your clearly defined steps in the middle. You are reviewing. So this place, you're just confirming, does it work in all cases? Is this doing what I really want it to do? Thinking back to some of those questions you asked in the understand phase. Did I document this? Can I give this to other people so they know how to repeat this task, right? Back to our example, customer enters the shop, little asterisk here. This assumes that the spider problem has been fixed, right? Their terrible Yelp review, they saw a spider, they walked out of your store. I would do the exact same thing. You fix that problem, you walk through this process and you convert it to a sale. In the review phase, you want to make sure that you've written down all the steps that you took here and you've handed them to the next sales associate so that when you leave the store, they can also do this task, right? In software development, this is our documentation. This is making sure you're communicating with other engineers that are on your team. This is also a place to ask, like, what would you do differently, right? Ideally, you would have caught this customer and you would have been able to tell them, like, I'm so sorry, I don't know what happened. You would have killed the spider on the spot, right? Whatever the situation is, in your personal example that you're thinking about too, you would be able to, you know, do that differently and learn for next time. And then finally, example, button click, any number of tasks. Maybe you arrive at google.com. That was the goal all along. And yeah, so I want to pause really quickly. First Slido. And I've got a few questions for you. I know there's a bit of a delay, so I'm going to open this up. Hopefully some of you have Slido open and you see it. Let's just start with a pulse check. How is this feeling so far? This process of Uber. Options here are awesome, pretty good, just okay, and totally confusing. Also, feel free to use the Slido Q&A to ask any questions here. Awesome. I'm so glad. So glad. All right. All right. I'm seeing a couple of people say awesome. So we're gonna say that that's awesome. Cool. Let's check our knowledge here as well. So glad people are feeling good. Let's ask another question. In which stage of Uber do you focus on thinking like a villain? Everything that can go wrong will go wrong. Is this understanding, planning, execute, or review? We've got 50-50 split, plan, execute. You're both right. The one in which we talked about it, execute, is the place where you're really like doubling down on thinking like a villain, although thinking like a villain as early as possible is probably a good thing to do as well. Awesome. Cool. So I am going to go ahead and stop that poll. And give just a minute or two for any open questions. Our next section is going to be practicing this in Scratch, which is a visual coding language. So we'll get there in a second. But any questions you have about this process, go ahead and drop them in the Q&A. Okay. All right, question. What are other spaces in which we can apply this mindset? I love that question. Great question. So everywhere. We're gonna get to that at the end of this, of like places that I think this can be a really effective problem solving mechanism, but the real answer is truly anywhere. You can apply this mindset in your work, whatever you're doing in your day to day. So someone said they're like an Instacart shopper. I think that's an awesome example. Thinking through the process by which you move through a store to pick up groceries for a person. I'm sure Instacart has suggestions or whatever, but you could do that in a really, really efficient way using this process by understanding, you know, where are the vegetables, where are the frozen things, navigating through the store. I think that's super interesting. You can use it in, you know, your personal life as well. I think there's a lot of problems that can be solved with this process. I'm old. Can I trademark thinking like a villain? Sure. I don't think it's trademarked. I'll let you know if I find out something differently. Cool. Awesome. Okay, let's move on to Scratch. So this is our task today. We are going to make the bear walk. So go ahead and head with me to scratch.mit.edu. The link is also below me. And then click create. And that should open up a page that looks something like this. I don't want these here. I'm going to delete these so we can start fresh together. Awesome. Give folks a couple seconds there. Cool. All right, so like I said, our task here today is to make the bear walk. Our first step is going to be understanding the problem. Actually, I'm getting ahead of myself. Let's do a little tour of Scratch. So like I said, Scratch is a visual programming language. It was designed by MIT with the purpose of like teaching kids how to code. I think it's a really useful tool for anyone learning how to code. I think, like I said, I think that learning science and technology should be fun and whimsical. And so, yes, we are thinking like children here a little bit, but it's fun. We all have that side in us, so I think it's great. Um, so it's these little things over here, you can basically stack them together. And these translate to types of things that you would do in code. So there's inputs, there's outputs, there's tasks all in here, and stacking them together, you can create results that will show up over here. So this is our sprite. They coined that term, and so we'll stack blocks together, and we can make we can make this sprite do things by the blocks that we stack together. So that's our little tour. Scratch is really powerful. I pulled up this example of some game that someone made. This is called Flat Cat. So you can see the cat like fly and like you get points. Oh, wow. Oh, that's the best I've ever done. And yeah, so they stacked tons of blocks together. They used coding principles like conditionals and loops, which we'll use some of those today as well. But I just want to show like the power of this tool because I think it is really fun if you're trying to just learn more about the principles here. Great. So someone in the chat saying the questions on polls and Slido. Yeah, I think there's like a pretty significant lag between the stream and when I'm clicking the buttons on Slido. So I apologize for that. But I'm doing my best to pause, but I'll make those pauses a little bit longer. Cool. So let's start here. Our first task is making a bear walk. Before we even get into Uber here, I want to recognize that this is a cat and not a bear. Show us how we can switch that. So we can change our character by coming in here, and I'm going to pick bear walking. Which for obvious reasons, we need a bear walking to make the bear walk. If you wanted to play around with Scratch, you would be able to use lots of different sprites, upload your own sprites, whatever, but we're just gonna start here with the bear. Cool, so let's do it. Making a bear walk. First thing we need is an input, thinking back to our algorithms. And there's lots of inputs here. I could click this green flag, I could click on the bear, I could click a key on my keyboard. Any of those would be acceptable inputs. My problem didn't give me one that I needed to use. So we'll think on that for a second. I think I'm probably going to go with the flag, but in this stage of the planning process, these are the types of questions you should be asking. You can either make those decisions on your own or go back to like your stakeholders and folks to help you figure out those answers, right? Depending on the situation. Other questions like, what is walking? If he moves, is that walking? Or does he need to like actually move his legs? Does he need to stop walking at some point? Or should he just like walk, off the screen? Again, I'm going to go ahead and make the decision here that walking should include moving his legs, and it should include walking from here to here, right? So I'm understanding my problem a little bit better now. So let's start. So I want to start with my planning phase. I've already decided my first step is going to be some input, and it's going to be clicking this green flag button. And then I want the bear to walk to the other side of the screen. So now I'm getting into looking at the tools that I have available to me. I invite everyone to do this along with me. If you aren't already, you should open up Scratch and look through this with me. So first thing I'm going to do is find the block that can be my input. And actually found this one down here, which is when the green flag is clicked, I want something to happen. You may have noticed that there's a move 10 steps option. That seems like a good place to start. So let's go ahead and green flag clicked, move 10 steps. And let's see here. I'm just going to click go. I'm going to see what happens. So he does move. My bear is moving. But according to my plan, that doesn't really count because I'm missing a couple of things. I wanted his legs to move and they're not moving yet. And I wanted him to walk all the way across the screen. So maybe I'll just say move like 1,000 steps. I want to see what'll happen there. Okay, so that's better. I got the bear to move all the way across the screen, but I'm still missing that element of legs walking. So what we want to do now is actually refactor our code. So we're basically into that review phase. We tried something, it looks, you know, unexpected. It's not really what we want. So I'm going to go back and do some additional research, start thinking about exactly what I want here. And so I know, because I've used Scratch before, that my bear has a bunch of costumes. And each costume is a different position that his legs are in. And so I want to utilize these to make my bear walk. And so what I'm going to do is I am going to say, when I click the green button, I want to switch the costume to A. And then I want to switch it to B. And then I want to switch it to C. And I probably need to move at some point. So let's move one step in between each of these. Or 10. 10 works too. Move 10 steps. And switch to D. It's kind of taking a while, isn't it? Maybe we should fix that, huh? Switch to E. Move. Switch to F. All right, I feel like that's enough. Let's see what happens when I click the screen button. Okay, what? That's weird. So he's definitely moving, but he doesn't look like he's switching at all, which is strange, right? So this is one of those places where I have to pause and think again. Let's think critically here. I know that because I have all these steps, like he must be moving to all of the costumes, but for some reason he is not. I can't see it, and that's because it's all happening at exactly the same time. So what I need to do is I need to put a little wait control in between each of these. So let's make it wait like 0.2 seconds. And let's see if we can see a little more clearly what's happening here. All right. And one more. All right, let's try that. All right, so that was really exciting. We got much closer to what we wanted here. The legs are moving, click the green flag, legs are moving, he's walking. The only thing I'm really missing is him getting across the whole screen. So I could keep adding blocks and make this just like a really, really, really long chain of commands, but I actually don't want to do that. This is where we're moving into that final review phase. So we've executed several times and we've gotten to a point where we feel comfortable with our solution. This is like pretty close to what we wanted. If I keep clicking the green button, it works. I'm happy with it. But what I want to do now is think about how could I make this more efficient? Now that I know my solution has to include costumes and not just steps, it has to include this wait code. I really wish that there was something here where I could just tell it to like repeat and switch to the next costume. Wouldn't that be nice? Well, let's look, shall we? And just as I expected, we can repeat, which is great. And I'm gonna go see if I can just switch to the next, and I can't. So let's just say switch to next costume. And then let's include in this repeat loop, I want it to move. And I know that I need that wait, 0.2 seconds. So let's see what happens here. Awesome. So this is super exciting. It's doing exactly what I wanted, but with significantly less code. And if I had this repeat maybe 30 times instead of 100, I could get him to walk all the way across the screen, which is awesome. So we just walked through the entire process of Uber. We first started with understanding what our task at hand even was, making the bear walk. We got into planning out, dragging our blocks together, figuring out what did work, figuring out what didn't work, and we refactored it into this really nice, concise thing that includes a repeat block, which is really exciting. This is like one of the foundational principles of software development that you would learn more about if you or to enroll in Lambda school or something like that. Um, so what I want to do next is, I want to give y'all 5 minutes to try this on your own. So I'm going to encourage you to open up a new Scratch window and make the dinosaur dance. And then during this time, I will be answering questions on Slido as they come up, and in the YouTube chat. So your task here: make the dinosaur dance. Let me know what questions you have. We'll reconvene when that timer is up. Um, as I'm waiting for the stream to catch up with what I'm saying, this is also a good time to mention, if you're enjoying this, if you're still here, potentially this coding thing, this solving problems thing might be for you. Like I said, right, coding is not just staring at a screen, right? It's problem solving. It's thinking really critically about lots of things. So if you're thinking like, hey, this is fun, I want to do this more, I would really encourage you to go into the links below, check out the Lambda School website, talk to an enrollment advisor, or start some of our mini boot camp series to learn like website development and a little more codey type of coding as well. Awesome. And it looks like we have a question in the Slido. What companies have I worked with in the IT space? Have you used this method anywhere else? So I'm going to answer this a little bit differently than you might want me to, Justin, but I personally haven't worked in the IT space. I've been a teacher and worked at Lambda School for a long time. However, this is the method that we teach at Lambda School, and our grads have gone on to Amazon, Twitter, Tesla, Uber. We have a whole list of companies on our website of places that our grads have gone, and they use this method in their problem solving and especially in their technical interviewing. So it definitely is like a tried and true method, but I would also love to hear how you're feeling about the whole thing as well. All right. Since I'm not getting a ton of questions, I'm also just going to start this poll. How's Scratch feeling so far? If people need help with that, I'm happy to go over it some more as well. And if you successfully made the dinosaur dance, I want to challenge you to make the background color change on key press. So this would be a second input, so not just the green flag, but now you're also getting these key press inputs. And if you want to really challenge yourself, change it to a certain color based on what key they press. So if the user presses R, change the color of the background to red. If they press B, change it to blue. Kind of start playing around with conditionals and multiple inputs like that. All right. Give y'all that final minute. This is also representative of something that we do at Lambda School. So when you come to Lambda School, you'll have these guided project sessions in which an instructor will be working through something like this, usually with a lot more code, but sometimes more theoretical like this one has been. And we'll do breakout sessions where you can work through these types of challenges on your own to make sure that you're cementing the material as you're going along. So just another plug. All right. If you successfully made the dinosaur dance, please let me know. Put it in the chat, put it in the Slido. I would love to celebrate that win with you. But I'm gonna just go ahead and move on to the last little section here, which is talking about this in real life. So I mentioned, like, I think this is a really powerful tool, not just in software engineering, but in any kind of problem solving that you might encounter in your work or in your life. So I want to show some examples of technologies where I have used these mindsets that I've learned about coding to solve problems. So not just me, lots of people. So like I said, if you really enjoyed this, like question, test, refactor process, you can apply it in so many areas. If you use Excel or Google Sheets or any kind of database, there are super powerful tools to be able to create these kinds of algorithms, right? They are literally input output tables. So you can manipulate them in tons of different ways. Google is your best friend when you're trying these kinds of things. So you can say, you know, ask Google a question, it will give you an answer. How do I do this thing? There might be a shortcut or a command in Google Sheets for that, which is exciting. If you use like Gmail, any kind of email, there's tons of integrations to automate your life and make it so much simpler. If you always send a customer an email after they came into your store, you can automate that. You can use Gmail, you can use Salesforce. This is like a really light entry into thinking like a computer scientist, thinking like a developer, and you may love it. Another place like social media, if you are a social media manager or you are a small business owner using social media, you can use this process to think about, you know, how often do I want to post on social media? What kind of post do I want to make on social media? Do I want to prepare them all at once? Can I automate when they're posted so that I don't have to do that? The answer is yes. You can do all of those things just by like applying this type of thinking. And then finally, there also are a lot of like low code, no code types of tools out there that I would encourage people to try if they like this. So Webflow is helps you build pretty websites. Zapier lets you do like input type output automations. Airtable is really great for building like legitimate, cool relational databases. Shopify and Retool, others that are like a little bit more advanced, but can help you apply this kind of thinking in your life. So my challenge to you as I'm wrapping up here today is to solve a problem in your daily life using this Uber framework. Check out tools like Zapier, check out any of those tools on that last page to do some like light coding types of things. And then if you like that, I have to end with this plug. Maybe Lambda School or learning more software engineering is right for you. If you're still here, either you're my friend, you're related to me, or you are really interested in this kind of stuff. So my encouragements are visit lambdaschool.com, attend another event, talk to an enrollment advisor, start an application. We've got lots of free material that you can work through before you commit to this program. So if you like this, definitely keep playing with it, playing around, make it fun. Just try solving problems that work for you. I'll stick around for a little bit longer to answer any questions people have about Lambda School, about this method, or anything else. But thank you for coming to my little chat today. I have enjoyed it and appreciated all of your attendance. Awesome. Thank you for your thanks. Appreciate you all. There's more good stuff where this came from on lambdaschool.com. Just saying. And also, I think your son would like this too. Like I said, this is a kid's tool. I like it because it's whimsical, and I think that kind of thing is fun. I know some people might think like, oh, this is like for kids. Like, why am I doing it as an adult? But I don't know. You learned something. This is a for loop. That's exciting. It's a big deal. All right, awesome. Thank you, everybody. I'm gonna go ahead and stop the stream. Thanks again, and have a wonderful evening.